Dear friends, welcome to this lecture on GSM and TDMA technology. Already I have covered some portion. Let me go through the revision. Here we are going to discuss services of GSM, network components, concept of GSM networks, channels, logical channels and physical channels, TDMA concepts, mapping of logical channels to physical channels, call setup, location updating and handover operations, as well as interfaces. GSM is a second generation network which is used to just send voice services and data delivery. When you look at history, it is found in through ETSI, European Telecommunication Standard Institute. There are three services: teleservices, bearers or data services, and supplementary services. Bearer services are done through the data rate of 300 to 9600 bits per second. Short message service SMS is also a bearer service. Voice mailbox and email is also a bearer service. Varieties of supplementary services are also present: call on hold, call varying, multi-party call conferencing, and etc. GSM is having frequency spectrum of 900 MHz, where uplink and downlink frequencies are as shown, as well as it also comes through 1800 MHz band. The carrier separation is 200 kHz. 124 carriers are present, and the modulation method is JMSK. Data rate achieved is 270.833 kilobits per second, and the multiple access method is TDMA and FDMA, called as hybrid multiplexing. These are the channels: primary GSM, extended GSM, railway GSM, GSM 1800, 1900, 450 and 480. GSM transfers the data through time slots. One time slot is one physical channel, and there are 8 time slots in a one TDMA frame. These are exchanged between BTS and MS. In order to invoke these functions, there are some message parts. For example, suppose a landline call is there, then that will invokes ISTN user part, and then GMSC invokes message application parts. Message application parts provide roaming number, acknowledgement of roaming number, and afterwards only there will be a routing information setup will be done. GMSC is a very important component. It requests the current routing address through MSRN with the help of HLR and MAP, message application part. MSRN is generated by VLR and HLR. Here is a graphics where you can see how the data transfer will take place. MSISTN is the number exchanged. MSRN is generated. Last 7th step, TMSI is generated in order to hide the identities of the correct IMSI number. Important parts: MSC, GMSC, VLR, HLR, authentication center, equipment identity register, and all. Already these are discussed in the class. Important part of mobile station is SIM card, subscriber identity module. Mobile equipment is identified by International Mobile equipment identity for voice and data transmission. Power levels are in the range of 0 to 20 watts and 160 character long SMS. SIM card is identified by IMSI and it is used to send and receive the calls between the subscribers. There are three important identification keys are there: KI, KC, cipher key, identifier, subscriber identification key, A3, A5 and A8 algorithms. Advanced encryption standard algorithms. SIM is also protected by personal identification number. Base station system is having BTS or BS and base station controller. Standard interface which is used between base station system and the mobile station are BTS and MS. Important function of BTS is encoding, encrypting, multiplexing and modulating and feeding the RF signals to the antenna. Involves in frequency hopping. Frequency hopping means carrier frequency are switched at the random order. Communicates with mobile station consisting of transceiver units. Transceiver converts incoming voice to PCM signal. Base station controller manages radio resources, assigns frequency time slots, assigns channels, transcoding, handover, power control and communication between MSC and BTS. Next important part is network switching system consisting of a very important component called as MSC, which is the heart of the network, manages communication between GSM and other networks also. That involves in call setup, call routing, billing information, register the mobile station is important, does location updating, as well as it also involved in inter BSS and inter MSC handoff. Some important components of NSS are HLR, permanent database, contains IMSI, MSI, STN, prepaid, postpaid, roaming restrictions and other supplementary services. VLR is a temporary database. Whenever new MS enters into the area, HLR database controls the mobiles in the roaming area. Database contains IMSI, TMSI, MSRN, MSI, STN and location area, authentication key and all. VLR generates TMSI. Authentication center protects the authenticated subscriber against the intruders, maintains 128-bit random number, 32-bit signed response and KC, cipher key is associated with HLR. Equipment identity register maintains handset IMEI numbers. It is having white list, black list and grey list. Black list involves all the mobile handsets which are not in the use. Grey list involves about to expire IMEI number cases, as well as white list involves current IMEI numbers in the operation. Only one EIR is present in one public land mobile network. GSM operation has been already explained in the class, involves speech coding, channel coding, interleaving, burst formatting and ciphering and modulation. Before the modulation, all these important operations will take place and the final data rate, as you can see, is 270.83 Mbps, and the reverse side, all the demapping reverse operation will takes place. This is according to the book. Some of the components which are not explained in the previous slides: SMS gateway, flexible number registers which is used for number portability. Whenever the question is asked, you have to draw this architectural diagram in the examination. Again, this is having all the components what I have discussed earlier. BSC and MSC communicates through a standard protocol called as LAPD, Link Access Procedure through D-Link channels. LAPD protocol is a data link protocol used in the ISDN. Transcoder controller converts voice into PCM. Network switching system handles GMS service. Already I explained about HLR database, TMSI, AUC, FNR provides flexible number register, provides the number portability, maintaining the same MSISTN number but only changing the GSM system operator. When you look at the interfaces between the components, UM interface is the only wireless interface, and other all interfaces right now may be wireless or wired. And for example, like C, which connects between MSC and HLR, may be optical fiber link or may be wireless. Both cases are true. GSM network involves MSC, MSC involves location area is involving BSC in turn involves base stations. So MSC is composed of varieties of location areas. When we talk about 900 MHz frequency band, there are 124 channels, each of 200 kHz each. That means one channel can have 8 time slots. The uplink and downlink is having 3 time slot delay. The channels are categorized into physical and logical channels. Logical channels again categorized into control channels and traffic channels. Control channels are divided into broadcast channels, common control channels, and dedicated control channels. Broadcast control channels are divided into broadcast control channels, synchronous control channels, and frequency correction channels. Broadcast channels are used only in the downlink. It carries the cell global identity information or location identity information. It sends the control information to mobile station, and it is always providing a periodic location updating facility for the mobile subscriber whenever this mobile is in the switched on condition, even it is involved in the call or not. Synchronization channel helps in getting the next immediate TDMA frame. It also sends the identification of BSC value to the MS to be connected properly. The BCCH information always alerts the surrounding 6 cells. It also selects the best 6 cells which are having a good received signal strength. SCH information is stored in these cells so that MS may quickly resynchronize when it enters into new cell. Synchronization means, as I explained in the class, if suppose the subscriber is in the call, he will immediately get the next frame in order to maintain the continuity of the clock whenever he enters into the new cell. One more important channel is frequency correction control channel. Whenever mobile goes to different cells, new cells enter into the new cells, it immediately tune to the cell's frequency. This is done by flag setting. 4 common control channels are there: random access channel, paging channel, access grant channel, and cell broadcast channels. Random access channel helps the mobile station to assign with the network. It gives the access to the mobile network, and whenever mobile initiates the call, it also responds, RACH responds to that page whenever there is an incoming call is there. Paging channel always helps to assign with the MS and is used by the BTS. Access grant control channel is used by network to assign the signaling upon the successful decodation of the burst. Burst means number of bits. So Decoding a burst means getting an information and getting access to the mobile network. So RACH and AGCH works in random. RACH gives the access to the system, as well as the access grant channel provides the exact access to the system by taking the burst and decoding them. Cell broadcast channel always gives the received signal levels and display it on the screen. It always displays the cell site or cell area where the mobile station is latched. There are three dedicated control channels are there. One is stand-alone common control channel, slow associated common control channel, and fast associated common control channel. Stand-alone dedicated control channel always used for location updating, SMS transfer, and authentication. Slow associated common control channel sends the control information or the power control in downlink and measures the reports, link quality reports in the uplink. Fast associated common control channel steals the traffic channel whenever the mobile wants a traffic channel to send its information. FACCH first tags or steals the traffic channel. The FACCH is used to carry out the authentication operation, handover operation, and immediate assignment of the channel also. Please remember, channel assignment is only done through BSC. There are two important traffic channels are there. One is full rate and the other one is half rate. Again, further subdivided into net rate and gross rate. If one TDMA frame involves 8 subscribers, then it's a full rate traffic channel. If one TDMA frame involves 16 subscribers, then it's called as half rate channel. Net rate refers to data rate before channel coding of the GSM signal processing, where gross rate refers to data rate after channel coding. This is the revision. In a full rate, first TDMA frame is always a traffic channel, and there are two frame structures used. One is 26 frame structure, another one is 51 frame structure, which is fixed by the GSM network. Half rate involves every alternate frame consisting of traffic channel, or every frame contains the traffic channels in a 26 frame structure, or it is also true for 51 frame structure. What is a 26 burst traffic channel? It's a fixed traffic channel burst. So this indicates the one-way propagation, two-way propagation, uplink and downlink setup process. Another important type of GSM signal processing or data transfer is bursts. There are 5 bursts: normal burst, frequency correction burst, and synchronization burst, access burst, dummy burst. Here, please understand, frequency correction channel and synchronization channels are operating through these bursts. So FCC and SCH will bursts are converted into the channels later. So FCC gets frequency synchronization correction burst, and synchronization channel gets synchronization burst, and RACH and AGCH burst information is present in access burst. Last one is dummy burst, which is having interesting feature. Normal burst is useful to transfer the data. So here is 8 time slot. Please check the time period, 4.615 millisecond. Every time slot I will focus here. TS2 is a time slot is having or may contain one burst of information. The first burst is normal burst. In the normal burst, we have tail bits, 57 encrypted bits contains information, flag bits, training sequence bits, which are used for equalizer frequencies or frequency corrections. Here you can see both sides are having information in the form of 57 encrypted bits. Then the last part is guard period. This is normal burst, similarly frequency correction burst, which consisting of 142 fixed bits, which is used for tuning the frequency, and it becomes the frequency correction channel later. Similarly, synchronization bit burst, 64-bit synchronization sequence used for synchronization channel purposes. Access burst used for RACH and AGCH, getting access to the system. Getting access to the system is done by synchronization sequence as well as encrypted bits. Here the guard pair bits are increased from 8.25 everywhere here to 68.25 bits. Then there's a dummy burst, which is just used to check the continuity of the GSM network operations. It involves two sides, 58 mixed bits, tail bits and guard period bits. Normal burst consisting of 57 encrypted bits. These encrypted bits consisting of information, call information. Training sequence consisting of zeros and ones, which is used to train the adaptive equalizer in the mobile GSM receiver. That means always, as you know about fuzzy logic, in the fuzzy logic, training sequence is used to tune the network such that it can transfers the data properly. Here also training sequence, which consisting of number of zeros and ones, which is used to get the adoption of the equalizer. Tail bits consisting of 3 zeros, they are unmodulated bits. They provide timing or initialization of digital circuitry, and they will initialize themselves. That means the digital circuitry, for example, a clock initializes from 0 seconds. So for all initialization purposes of the GSM network, these tail bits are used. Training sequences are used for training the equalizer. Equalizer always adjusts the frequency of the GSM receiver. Flag bits separates the training sequences from encrypted bit groups. All information in the GSM is always converted into some form, that is encrypted form. These flag bits indicates whether the encrypted bits contains traffic information or control information. So for example, if a flag bit is set to 0, it may contain control information. Flag bit is set to 1, it contains traffic information. So the 57 encrypted bits in the normal burst may contain traffic information or control information. Then the guard period. In the guard period, which you saw in all the bursts, which is consisting of 8.25 bits, here there will not be any transmission activity takes place. But when the normal burst is used as a traffic channel, 114 encrypted bits are delivered per time slot. 57 plus 57 is 114. 114 encrypted bits are delivered per time slot. Then other bursts are frequency correction burst used to obtain the synchronization. If mobile and base station are if suppose base station is continuously sending the frequency correction burst, then the same GSM frame structure which receives the frequency correction burst will convert it into frequency correction control channel. In the same case, the encrypted bit containing information of the frame number and the base station identification code, repetition of synchronization burst by base station through GSM frame structure becomes synchronization channel. Where I said many times there are two pairs, one is synchronization burst and frequency correction burst, another pair is RACH and AGCH. Excess burst, that's what I am mentioning, it always facilitates the access request and handover operation. Here there may be extension of guard time, mobile become active acquiring that access burst channel, so that's why there will be extension of guard time is there. The excess burst is only transmitted by the base station with the maximum radius of 35 kilometers. Suppose we are not having the network, sometimes network goes off sometimes because of this excess burst is not accessed by our mobile station. So excess burst is used by RACH and FACH. Excess burst is most important during handover operations. The excess burst is very important, so that's why RACH and AGCH are very important channels. Very important bursts. There is a dummy burst which always ensures that base station is carrying some frequency information, does some power measurements on the strongest base station, and which base station is to be attached when EMS mobile station first turned on, also makes measurement of other base stations providing information when during the handover process. So this is the sequence once I shown you in the class. This is 51 frame structure, 26 frame structure and 51 frame structures are used. The first channel is frequency correction channel, next is synchronization channel, next is broadcast channel. In the next sequence of burst after 9th frame, you will get C1, C2, C3, C4, C5, C6, all are control channels. So this is the another important GSM signal processing diagram, where first process is signaling 184-bit signals with a 20 millisecond information, speech coding, channel coding, interleaving. As I said, interleaving means removal of erroneous bits from the number of bits. Then burst formation is grouping of bits, and we already know there are 5 bursts are there. When we want to transfer the burst, normal burst is selected. Ciphering, modulation. The next side involves demodulation, deciphering, then burst deformatting. Bursts are again converted back into number of bits. Then de-interleaving, the bunch of bits which are selected in a basket, which are again clubbed into number of bits. Then the last step is channel decoding, then speech decoding. So overall this operation starts with 13 kilobits of information, and finally we'll get around 280 kilobits per second data rate. So interleaving, the channel coding always consisting of 456 bits, but interleaving retains all these 456 bits. As I said, there are two types of formats. One is 26 frame format, another one is 51 frame format, but the basic structure of all the control channels uses the same format. First is frequency correction channel, next is synchronization channel. Other channels may be broadcast channel or control channels, which may be represented by X. Here is one more time I am showing you the frequency burst, 3 tail bits, 8.25 guard pair bits, synchronization burst, dummy burst, access burst, normal burst. Normal burst is very important. Actual voice communication data will be put in these two sides of 57 encrypted bits, followed by 2 flag bits. Flag is set to 0 whenever these 57 bits contain control information. Flag is set to 1 whenever these 57 data bits are consisting of traffic channel information, followed by 3 tail bits both sides, helps to gain the initialization, or helps to initialize the frequency of the equalizer of the GSM receiver. Frequency initialization is done by tail bits. Here you can see the formats FSB, then random access bursts, access grant bursts, which are shown by C, then dummy burst. So B indicates broadcast burst, R indicate random access burst, C indicate AGCH, this access burst, and D indicates dummy burst. That's how all these bursts will be put in one of the frames. Then these physical channels are grouped into hyperframes. Suppose there are 2048 frames are there, then that is called as hyperframe, which is having a time period of 3 hours 28 minutes and 53.76 seconds. Each hyperframe consisting of one superframe. These superframes are available in 51 data groups, 51 group formats or 26 group formats.